This demonstration will compare the business intelligence query performance of IBM System Z running DB2 for ZOS and the DB2 Analytics Accelerator with that of a competitor's data warehouse system. The Analytics Accelerator, an appliance based on Netezza technology, is connected to System Z to speed up complex analytic queries sent to DB2 for ZOS. DB2 transparently redirects queries to the Analytics Accelerator, meaning users don't have to change anything in the way they access DB2 for ZOS. The accelerator requires very little, if any, tuning to achieve excellent performance results. With this technology, System Z can now provide the best possible performance for both large transaction processing workloads as well as for extremely complex analytic workloads, all within a single platform environment. This test application allows business intelligence queries to be submitted to DB2 for ZOS and the DB2 Analytics Accelerator on the left, or to the competitor's system on the right. SQL queries are submitted to the data servers using a JDBC connection, and the time to complete each query is measured and displayed on the screen. The BI Day test data warehouse is loaded into both data servers. Each server contains the same 9 billion records, or approximately 1 terabyte of data. The queries used in this test represent two general categories of business intelligence reports: intermediate reports, reports 9, 10, and 11, and complex reports, reports 1 and 3. These queries are the actual SQL generated by the Cognos BI application when rendering these reports. The SQL is identical in both test applications. So let's get started. In each of these tests, I will give the competitor a head start. Let's start with intermediate report 11. I'll start report 11 in the competitor window, and now I'll come over and start report 11 in System Z. You can see the elapsed times progress as the queries run, and when the queries complete, an actual execution time is displayed. Okay, both queries have completed. You can see that System Z completed report 11 in 5 seconds, while the competitor completed report 11 in 12 seconds. It's the same SQL running against both systems, and therefore the same 200 rows are returned from both systems. The test application only displays the first 10 rows returned in the results set. Since these queries don't include any ordering of results, each system will display the rows in a slightly different order. So for report 11, System Z was about 2.5 times faster than the competitor. Let's move on to report 9. Once again, I will start the competitor first. Report 9 is an intermediate report. The intermediate reports, reports 9, 10, and 11, are more selective than the complex reports. For example, for report 9, of the 9 billion records in the data warehouse, only about 10 million of those records meet the criteria in the query's where clause. We can take a look at this where clause by scrolling to the bottom of the query. You can see the where clause specifies that retailer site key must be one of these 5 values, and the month value must be either January of 2004 or September of 2006. I'll go ahead and start the query in System Z now. Although I've submitted this query over a standard JDBC connection directly to DB2 for ZOS, System Z has automatically and transparently redirected the query to the Analytics Accelerator. The accelerator is very efficient at accessing only the records required to satisfy the query, which eliminates unnecessary I/O and greatly improves performance. The net result of this design is that with the DB2 Analytics Accelerator, System Z performs queries much faster than the competitor, finishing in only 6 seconds, while the competitor took 58 seconds. That works out to approximately 9.5 times faster performance with System Z. System Z returned 80 rows, and the competitor also returned 80 rows, again in no particular order. Now, some reports are less selective and are therefore more data intensive. For example, reports 1 and 3 require that all 9 billion records be accessed and aggregated to produce the final query result. As queries become more complex and more data intensive, the massively parallel processing architecture used by the Analytics Accelerator really shines through. With data-intensive queries like this, the performance advantage of System Z with the Analytics Accelerator becomes quite dramatic. Let's start report 3 on both systems and let them run, once again giving the competitor a head start. Okay, after 2 minutes and 42 seconds, System Z has completed report 3, accessing and aggregating 9 billion records from the data warehouse and returning 6,300 rows. Again, we're only showing 10 of those rows. The competitor system is still running and will be for some time. We're coming up on 10 minutes in the competitor query execution for report 3, and the competitor is still running. The competitor is now approaching 20 minutes, and report 3 is still running. Okay, at 23 minutes and 47 seconds, the competitor system has finally completed report 3. System Z completed this report over 20 minutes ago, around 7.5 times faster. Each system returned the same 6,300 rows. Let's move on to report 1. Once again, I'll start the competitor's system first, and then I'll start System Z. I'll check back with both systems in a couple minutes. Okay, after 1 minute and 35 seconds, System Z with the DB2 Analytics Accelerator has completed report 1. Report 1 accesses and aggregates 9 billion records and returns 5,895 rows. We'll check back with the competitor's system in a few more minutes. Okay, it took the competitor 18 minutes and 23 seconds to complete report 1. The same 5,895 rows were returned. System Z completed this same SQL against the same data in 1 minute and 35 seconds, 11.5 times faster than the competitor. So on the tests performed in this demonstration, IBM System Z with the DB2 Analytics Accelerator achieves superior performance than the competitor's system, and the System Z performance advantages improve as queries become increasingly complex and more data intensive.